number 5. So we were doing these last year, and then we got a little busy. So now we're restarting them thanks to Nicholas, who's our lovely community manager. And do you want to introduce, kick things off with housekeeping?
Sure. I can do that, but I'll hand over to you very soon. As Yan said, thank you so much for spending your evening here with us. My name is Nicholas. I work as the community manager here. We have 5 amazing speakers lined up for tonight. Already a huge thanks to them. And just about our agenda, we will start quickly by introducing a code chrysalis, and then we'll jump straight into the talks. And in the end, we'll have some time for some networking and mingling. Just for housekeeping, we do have bathrooms. They are straight there and to your right. We won't be having any breaks nor Q&As in between the talks because there are 5 of them. So feel free to go when you need to do that. And one more really important thing. We have a hashtag for tonight, which is CC MiniConf. So Twitter, whatever you may use, please take pictures, share on social media, and have a discussion on it. But without any further ado, I would like to hand it over back to Yan for our Code Chrysalis presentation. Thank you for coming tonight.
Hey everybody, so my name's Yan. I'm one of the co-founders of Code Chrysalis. I'm also the CTO. For those who are new here, who's new to Code Chrysalis? First time here? Oh, quite a few. Cool. All right, so I'm just going to introduce what we do. So we are a software engineering bootcamp in Tokyo. We're most known for our 12-week bootcamp. It's full-time, so 12 weeks, Monday through Friday, 9 a.m. to 6 p.m. Full-stack software engineering, and we're a bit picky. We have about a 20% acceptance rate. And I want to quickly talk about what our students look like. So what's interesting about our course is that it attracts people from all kinds of backgrounds. So we have people who do already come from a software engineering background, about 32%, have experience as a developer and or have a computer science degree from a 4-year university. We also attract a lot of other kinds of engineers looking to make a career change. So a lot of mechanical, electrical engineers. And then 36% of our class, give or take, are people from completely different backgrounds. So like English teaching, we had a ballet dancer in a class, we had a filmmaker, musicians, all kinds of different non-technical backgrounds. So again, our admissions process is a little bit picky. So in order to make it into our course, you need to pass our online coding challenge. And then it's technical interviews to make sure that you are at the technical level that we look for. So you can check out more about our admissions process at this link. And what does our curriculum look like? Well, here's a quick snapshot, but if you're interested in a more in-depth view, we have these flyers that are available outside. So they go a lot more in-depth into what we teach here. It's basically broken down into 3 sections. So the first section is our pre-course curriculum. So this is the curriculum that all of our immersive students need to complete before the program begins. And then we have 6 weeks of our very structured curriculum where we take them full stack. And then the second half of the course, the last 6 weeks, is focused a lot on projects and outcomes. So our students work on all kinds of different projects, including a tech talk. So all of our students are required to give a public tech talk on a topic of their choice. It's 30 minutes. All our students also have to pick a language that they've never used before, a programming language, and they have to build an app in that language in less than a week. So they get to do a lot of cool things like that. And the second half of the course, we're also helping our students find and get prepared for the job hunt. So we do things like technical and non-technical interview training, resume and cover letter writing, and even salary negotiation. And that support is provided even after our students graduate. So this is lifelong support. Now that we've had alumni graduate and be out in the field for over a year, we have some of them come back when they're looking for new jobs. and coming back to do mock interviews with us or just get our advice. So that leads to pretty strong outcomes. So we have graduates working at companies like Google, Sony, large companies like that, small companies like Coin and MoneyTree and Paydi. So a lot of really awesome startups and also big tech companies here. And we partner with some really awesome companies. If you are at a company that would be interested in partnering with us, whether it's on events or hiring, please reach out to me or Nicholas later. And we also have some part-time programs. So we have a foundations class, an intro to programming in JavaScript course that's 5 weeks long. We also have an English for engineers course. So it's like English communications, specifically targeted at people who work in tech and engineers. And we also have a blockchain class that's 2 weeks part-time. It's for developers only, and you're recreating a UTXO-based blockchain using TDD. So here's some information about foundations. We have also information about both our courses outside. And I want to invite all of you on June 1st to big MiniConf. So today you're at regular MiniConf. And every 3 months we have a big MiniConf because we are really great with names. Here are what our students are going to be talking about. So please come and check it out. The information is already on meetup.com. So if you're interested, please RSVP and we'll see you there. And yeah, you can find us on the internet. Next course starts July 8th. It's not too late to apply yet. And if you have any questions, feel free to come to me afterwards. Thank you.
Thank you, yeah. And without further ado, I would like to introduce our first speaker of tonight. So we're going to have lightning talks of 15 minutes, and we have Chiarng from Adobe. He's going to be talking about Product Management 101. So let's give a warm welcome to Chiarng.
Okay, I'll just present from up here. Hey everyone, I'm Chiarng. I'm visiting from San Francisco. And thank you, Nicholas and Yan, for the invite. This is all. You need to press the button once. Short. Just short. Hello? Ah, okay, much better. Yeah, again, my name is Chiarng, visiting from San Francisco. Thanks so much for your invite. I still remember when I first started seeing Facebook posts from Yan on CodeChrysalis, and it's just amazing how much has grown over the years, and really a testament to the strength of the community here and the work you guys are doing in terms of where the graduates going and being the core of the hub for the tech community here. So yeah, I'm really glad all of you could make it here. In fact, I almost couldn't make it myself. I don't know how many of you were following the news over the weekend, but I was on Yakushima, where apparently they experienced record rain once in 50 years, and almost didn't make it off the island. So earlier today, I finally caught a ferry and a flight back here to Tokyo. I'm glad I made it here in person. Glad to be here. And in my spare time, I moonlight as a product manager in San Francisco. Currently at Adobe, previously I worked for startups such as Sauce Labs and Proximity. Prior to that, Stanford Medicine doing healthcare mobile apps actually. So yeah, just by a show of hands, how many of you are product managers already? Okay. How many of you work with the product manager consistently as part of your jobs, as an engineer or any other role? Okay. Yeah, so whether you're very familiar with product management already or whether this is a completely new discipline to you, I want to be able to answer some of these questions for you by the time you walk out of here today. Why do product managers even exist? What do product managers do? And one of the questions I get most frequently when I come back to Asia is, so are you just like a project manager then? Like schedules and deadlines? No, that's not what we do as product managers. So I'll be covering some of that towards the end of the conversation as well. And one of the ways that I find it easiest to digest concepts is to look at what the trend over time has been, what history is. So in this case, how has product management as a discipline evolved over time? And really the primary driver for the modern discipline of product management really comes from the transition in software development from waterfall to agile. And so you're probably mostly familiar with it, but just as a quick recap, waterfall, we're shipping giant big bang releases, a ton of features at a time, in giant buckets of time, maybe once every 1 or 2 years. There's an emphasis on schedules and deadlines, all that fun stuff. With Agile, it's much more about shipping small, discrete MVPs that solve very specific user needs. Instead of having requirements, we have user stories. Instead of having schedules, we have engineering estimations. Engineering teams usually have own test-driven development. They have automated tests in a CI/CD pipeline. That allows us to really get to the core of Agile, which is to be able to iterate frequently. Delivery velocity is really key at the end of the day. So looking across the top here is a fairly typical framework for how our feature comes to life, right? You have discovery, which really answers the why are we building this, right? For who are we building it? What problems are we trying to solve? We have planning, which answers the what. What features are we building to solve these problems? What order are we going to build them in? So prioritization. Then lastly, we have execution. So how are we actually going to implement these features with the engineering team? In a classic waterfall, you will see the rows here correspond very closely to the functionality with the phases in waterfall. Your typical marketing team's going to do some user research, figure out what some of the problems users facing are. You have product management, which primarily owns a roadmap of features that solve those problems, come up with requirements and hand them off to the next team, which is usually project management. Project management then takes those requirements, starts coming up with schedules, Gantt charts, figures out headcount, bandwidth, all that kind of fun stuff, specifications, and then engineering actually ends up building. But in Agile, because we are shipping so much more frequently, you don't have the time for all these different roles to have to communicate and coordinate with each other anymore. And so that's really allowed a transition here for product management to take out the end-to-end of owning all the way from understanding who our users are, what they're doing, what their pain points are, what their workflows are, how do you even segment your customers if you're working on enterprise product, for example, all the way through getting buy-in from stakeholders on that roadmap. How do you set up that framework for prioritization? What kind of metrics do you define for success? How do you break down your features into actual engineering stories that you then estimate with the engineering team, then execute on a sprint-by-sprint basis? Then how do you measure the outcome, compare that to your assumptions, and then iterate all over again? And you will notice here that product management primarily answers the why and the what in the first two phases, but they're still involved in the how, which is although primarily driven by the engineering team. Product management and engineering work much more closely together in Agile in order to ship features together. So in order to answer the question of why do we have product managers now that we understand the history, I think we need to first answer the question of why do we even build products? Right? Is it just to meet deadlines? Probably not. Is it to make a lot of money? I hope so, but that's not the full story, is it? Really, at the end of the day, it comes down to two things here. And in order, that is meeting and even exceeding the user or customer needs. All right, having a very solid understanding of what their needs are, not just what they're asking for to be built, but really what are their core problems and what's the best way to really solve it. And then secondly, of course, we want to be able to make business impact here. And at the end of the day, for any product out there, the top level metric is still revenue. So from here, let's dive a little bit into what some of the value that product management brings really are. Starting from the top here, at the end of the day, it's about representing the customer or user voice here. And depending on what kind of product you're working on, there's a lot of different ways that you can go find that out. If you're working on a consumer application, you can build prototypes, run some experiments, figure out, hey, statistically speaking, what percentage of conversion rate am I looking at? For enterprise products, you can get in front of customers, actually talk to them, run surveys. But really, at the end of the day, you're trying to understand who are your users, what are their problems, right? Your users aren't just your current customers, they're also the market outside. Trying to understand what are their real needs, not just what they're asking for. Secondly is how do we prioritize what to build first, right? Different teams within your organization are going to want to prioritize different things, right? You might be working with a sales team that needs to hit their quarterly goal, and therefore they're asking for that next shiny feature to be built by your engineering team. Your engineers might be pushing back and saying, hey, we have all this tech debt that we created from last year. We really got to solve it. Or we have no ability to hit what we have on the roadmap and really scale to meet the demands of our customers and the number of new clients that we are putting on over the next year. So how do you handle those prioritization trade-offs? How are you defining metrics to measure success in order to have a data-driven framework around the prioritization? And then finally, how do you set expectations appropriately for the various stakeholders and your customers such that when you have that prioritization conversation, it's not a surprise to them, right? What you're letting them know is, hey, this thing that you're really interested in, we're not able to build that right now because we need to build this other thing in order to serve you better and your needs going into the future. But this feature that you're looking for, we're going to be able to slide into this other part down the road. So being able to validate your roadmap with customers is a large part of it as well. And then finally, one of the main misunderstandings that I hear often from aspiring product managers is this concept that, hey, why do you want to be a product manager? I want to be like the CEO of the product. And there has never been a bigger lie. Product managers don't have any authority at all, actually. Unlike a CEO who can tell their subordinates, hey, I want you to go build this, do it this way, and subordinates have to follow. As a product manager, generally speaking, your influence comes from your ability to be that accurate representation of users, your ability to find the right data, to justify the priority of something over another. And so at the end of the day, you have to make sure that you have relationships built up with the various stakeholders in your company in order for them to get that buy-in on your roadmap when you most need it. And finally, perhaps most importantly, as a product manager, making sure that your engineering team is also aligned with your roadmap and your backlog, that their priorities around, again, tech debt, engineering scaling, or even something as simple as improving the tooling in the pipeline are also being met on a roadmap and being facilitated and shared around the company. So, one of the next questions I often hear is, well, what does a product manager do? Okay, we understand why we need a product manager. You represent the user's voice, and you prioritize what we build. And this looks like a giant laundry list, because it is a giant laundry list. As a product manager, at the end of the day, what's most important is whatever it takes to successfully ship product for our users, right? There are the recurring things. You might be attending backlog grooming, sprint planning, demos, retros, daily stand-ups with your teams. You might be holding various stakeholder meetings to make sure you are kept up to date on the latest feedback from your customers. That you're working with customer success, support, sales, product marketing, sales engineers to make sure that they can put you in front of customers so that they can hear from you as well. You get an opportunity to validate with them. But at the same time, you might suddenly have an issue coming in from legal. Maybe some user realized that you needed to change something in your terms and conditions. And suddenly that entire week is spent talking with legal. So there's never really a consistent what you do as a product manager from day to day or even week to week. But at the end of the day, you are responsible for delivering to your users and meeting their needs. And so finally, not all PMs are created equal. What is the difference between different types of PMs? And when I say PM, generally speaking, I mean product manager, but sometimes I head back to Taipei where my parents are from, all my friends think project manager, right? What is the difference? And so while I know this is not the be-all and all of us do way beyond our job descriptions, obviously, and things differ between different companies. But in general, the core responsibilities that you might find as a product manager are, again, representing user needs, breaking those down into features, prioritizing those on backlogs and roadmaps, validating those, defining metrics, actually executing with engineering, and again, measuring and iterating, shipping product. But as a project manager, that's much more typically to do with making sure that you're following a schedule, meeting deadlines for certain phases, managing those dependencies and headcounts, Gantt charts, all that kind of fun stuff. You're often measured by how many projects you can handle at once, rather than whether the feature you're building is making the most impact. And project management, going back to one of my earlier slides, usually is a sign that the organization still fundamentally operates as a waterfall company. But moving off to the rightmost column there, program manager. I don't know how many of you have heard about program management before, but oftentimes this is a role that exists in larger companies, sometimes legacy companies, where their code base tends to be very entangled. And that means in order to roll out a feature, sometimes you need to work with 10 different engineering and product teams. And that's where having a program manager that can come in and help coordinate those high dependency and high complexity features between the teams, streamline communication issues before they even come up as an issue, really comes into play. And an experienced program manager can really help to expedite and streamline how we ship features in a very large company. And finally, coming back to the bottom here, sometimes you hear about product owners. And this is oftentimes a point of confusion. What is the difference between a product manager and a product owner? So product owner tends to be a Scrum specific role. And Scrum is just one implementation of Agile, where the product owner works with the engineering team, is on the engineering team, and is primarily responsible just for prioritizing the engineering backlog. So oftentimes they're the ones prioritizing bugs versus engineering stories versus stories that are tied to epics and features. However, not all product owners are product managers necessarily. The most effective companies I've seen tend to have product managers acting as product owners so that they really own the end-to-end. But there are definitely companies out there where product managers own the roadmaps and then hand it off to product owners to prioritize on an engineering backlog. But just wanted to point out that one is a subset of the other. And so really at the end of the day, even though I'm talking about titles, the title really doesn't matter here. You don't have to be a product manager to be the user's voice. If your team is missing that gap, or you're unclear about why you are building a particular feature, who is serving, what impact it's going to have, read the question zone. You be the voice of the user, and make sure that your team is building product in the right direction. Make sure that you're building the right thing, the right way. So with that, thank you so much for your time. Appreciate it.
Thank you so much for the talk. Without further ado, I would like to introduce our next speaker. We will have Brian, the CTO of Adco, talking about nuts, giving us an introduction to it. So please all welcome Brian.
Hello. Thank you. You sure? Yes. Perfect. Just give me a few seconds. This is turning into like an ASMR video where we all drink away from the mic. Perfect. All right, thank you everyone for joining us here tonight. Instead of watching the Game of Thrones finale, you're here, which says a lot about the crowd here tonight. Big thank you to Code Chrysalis for hosting. And thank you for Chiarng. Yes, for your presentation. It's really nice. I mean, there's a lot of technical talks here, but it's also good that some of the other roles outside of the just like the engineering department are highlighted. So it's very informative. Thank you so much. So I'm Brian. I'm the CTO of Adco. I've been in Tokyo for the past 8 years now. I've been working for startups on and off, early stage, late stage, also some bigger companies here in Tokyo. Front-end, back-end development, architecture, I've seen it all. So yeah, currently the CTO of Algorithmics. Adco is a SNS advertising ad tech company where we provide workflow optimization and performance optimization for agencies. I'm also on Twitter, but it might not be for everyone. You can check out my blog, which is for everyone. So yeah, you're not here to find out about me. You're probably here to learn more about nets. And I always start my presentation by quoting Sagan. He once famously said, "If you wish to make an apple pie from scratch, you must first invent the universe." Exactly, the universe. Nice, someone got it. Exactly. And it's the same with nets. If you want to understand nets properly, you must first know a bit more about messaging in distributed systems. And like most problems, they're really easy to explain, right? We have n services across n virtual machines or physical machines, or maybe they're on the same machine. But how do we make sure that these services can talk to each other? Well, for that we have some delivery models. And delivery is hard. Just ask FedEx, ask your local mail provider. Messages, they go across networks, they go across oceans, they go across water, they go across land. And if you're unlucky, or lucky because I think it's pretty cool, they also go through space, through satellites. And we need delivery guarantees for this. And as the name implies, they describe the guarantee of the delivery of your messages. And there's really two models that I want to talk about here before switching to nets. One is the at least once delivery guarantee. So we have a message from system A and we guarantee that we deliver it at least once, which means that we could deliver it once, it means we could deliver it twice, or it means we could deliver it as many subscribers as we have to a topic. So if you have 10 subscribers to a topic, we might deliver the same message 10 times. But hey, we are at least delivering the message. At the other end, there is the at most once delivery guarantee, which means that it will be delivered at most once, but at the same time, there might also be no delivery of the message. Which model works best for you is just something you have to figure out. Everything has its own drawbacks, everything has its own pros as always. There's never really an easy answer, ever with technology. Then last but not least, that's also important, is the order of the delivery. Like when you make cereal in the morning, you're getting ready to make your breakfast, what goes in first? Is it the milk? Is it the cornflakes? Let's say you send in 2 tasks into your queue at the same time. How do you make sure that your cornflakes are there before your milk? How do you make sure that your milk is there before your cornflakes? But of course, I mean, this is a very silly example because everyone knows that the milk goes first. If you don't agree, you can add me on Twitter. I will let you debate you on the topic. So yeah, those are like the delivery types we have. And then we move on to our messaging patterns, which is describes how our messages find their way to the consumers. So in any distributed system that is handled by a broker, I'm not going to be talking about brokerless PubSub or communication this time. If you're talking about a communication in your distributed systems, it usually goes through a message bus, which means your messages go through one or multiple brokers. And I think the most well-known topic, or the most well-known, what did I call it again? Messaging pattern, is the PubSub. So you have multiple producers who push multiple messages onto a queue, fans out to multiple consumers. And this is great for like real-time communication, such as chat, or if you want to push events, or if you want to gamble with your boss's money, you can use it to push like stock changes, like ticks. But also for service discovery, there are some tools out there that actually use nets for service discovery. Then there is the very popular queuing system. It's basically multiple consumers feeding off of a queue. It's pretty useful for distributing works. So let's say you are scraping a website or scraping multiple websites. So you spin up 100 workers. Every worker takes care of scraping a single website, and this is how you can like vertically or horizontally scale up the performance of your application. Useful for processing data. And last but not least, there is the request and reply. You have a producer, which produces a message on a topic. You have a consumer. Consumer replies onto a separate topic. Producer reads the result in. Et voila, you have your request and reply. So this is all capable using the wonderful tool that is Nets. Sorry, I'm going to do the ASMR again. And Nets has, like most Unix services, a single statement, which is to keep it simple. So we all know the more things something does, the more complex that thing becomes, the more likely it is to break down, the more likely it is to make our life difficult. Nets has been written in Golang and Apsira, which is infrastructure as a service. I'm not sure if people here are familiar with Apsira. I'm not. I had to look it up before making this introduction. It was written by Derek Collison, whose name I always read as Collision. He's from ex-Google, he's ex-TIBCO, and he has been building messaging systems for the past 20 years. And basically all of his experience accumulated over the time, and he created Nets. Nets is extremely performant. It can easily handle 100,000 messages a second on community machines. We use it at ADCO ourselves, and we run it on like some lowly machine, and we find out it can handle 10,000 messages a second without any hiccups. Out of the box, Nets does not support persistent messaging and queuing, but you can enable this through Net streaming, which is a separate daemon. So to this presentation, I will be talking about queuing a little bit, message playback. Just imagine I'm talking about Net streaming in that case. It's self-contained, there's no external dependencies, which was a huge plus for me. I will be talking a little bit later about alternatives to Nets, but the self-containment of Nets is really something that, that spoke to us. And everything pops up. So every messaging pattern we described earlier, it's all handled under the hood using pops up in Nets. And it has amazing client support. They are about 16, I got the math wrong here, please don't blame me for that. It got 16, it has support for 16 different languages, including the most popular one here probably in Japan, Ruby, Node, Go, Python, C++, C, Rust, you name it, there's probably support. And making support yourself is pretty easy as well because, nope, I didn't make this on this slide. It's, going back. It is an extremely simple protocol. It's a text-based protocol that looks like this. It starts with an opcode, followed by a subject, a possible reply to index, the number of bytes that your payload has to be, followed by the payload. And subscribing to messages is easy as well. You specify the opcode, or the opcode followed by the subject, a group, and possibly a subscriber ID. And all members within this queue group, which I will demonstrate later, will get the messages in like a round-robin manner. So there you have your like at most once delivery guarantee. So this is one of the messaging patterns to publish, subscribe. So you have a producer, you have a subject, and you have a shit ton of consumers who consume off of this message queue using this subject. And again, like I said, this is great for real-time chat or for getting messages across in real time. Then there is the queuing, in which case you can specify a group. And that means that when you have a producer who sends a message across a subject, all consumers within a group consume a message, but that allows you to do something like this. So let's say you have a purchasing service, right? You have a web shop, people buy stuff. And you could publish a message on a topic called Purchase Complete. And then if, as the group name, you could have audit service, and for the other group name, you could have email service. And the consumers within this group will take, so you have like this fan out. So it's like pops up, fan out, while making sure that the consumers within a single group receive the message at most once. So this is super useful because let's say, let's say a user makes a purchase and we want to send an email to the user like, hey, thank you so much for your purchase. But at the same time, we want to send our accountant a message saying, hey, listen, this shady guy, he bought something, you want to make sure it's all legal. Maybe you want to, update some statistics in the background. So you can do that using using Nets as well. And now we go to the part where we say, well, Brian, why not use one of these? Why not use Redis? So when at ADCO we have this we had a need for our microservices to communicate across each other. And we looked at Redis, but it was quickly ruled out because we needed at least some form of delivery guarantees. We can live with at most once, we can live with at least once, but we need some sort of delivery guarantee, and Redis doesn't let me. When I made the presentation, Redis didn't do that. There's of course ways to do it yourself, but Nats provide this out of the box, which was very attractive to us. We've used RabbitMQ extensively for our tasks, but the performance, as soon as you start to scale up across like 10,000, 20,000, 30 messages a second, you need a very powerful machine where, Nets is still handling a few, like I said, you got 50,000 messages a second on commodity hardware. With Rabbit, it was a bit more difficult, and the high availability support of Rabbit isn't exactly something to write home about either. And then we looked at Kafka, which looked extremely promising, but it's a bit heavy on the implementation side of things. It requires introducing a new dependency, Zookeeper, whereas Nets is all, like I said, it's self-contained, supports high availability out of the box, and using clustering setup is extremely easy. It uses the same pub/sub method to announce new servers to the cluster. So if you have a officially supported client of Nets, the high availability works out of the box. You only need to know the address of one server. All right, that's all. Thank you very much for your time here.
That's all, folks. Appreciate that. Thank you so much, Brian, for the talk.
Thank you.
Next one, I would like to introduce Raman from TDWA Hakuhodo, and he will be talking about utilizing AI within the marketing industry. So please join me in welcoming Raman.
Okay, hello everyone. Thank you, Code Chrysalis, for inviting me, and Chiarng and Brian. So just a little bit about me. My name is Rahman Hidayat. I know it's kind of hard to pronounce my name, so people sometimes call me Ribbit, which sounds like a frog, but that's okay. And in Japan, people call me Rafumato, or Raf for short. I've been living in 4 countries at the moment in the span of 10 years, and I've always worked in marketing / creative / technology related industries. And at the moment, I'm the technical lead for TDWA Hakuhodo. It's kind of hard to define, but I do programming, creative execution strategy, and business development. So on the video behind that, that's the work that I've done in these past years. So today I would like to talk about how to utilize AI within the marketing industry. So who's here work for a marketing related industry and has used AI of some sort?
I'm using AI but not in marketing.
Okay, that's cool. So thank you very much for that. So let's begin with Cannes, which is the largest international festival of creativity and advertising events in the world. There was a few interesting trends that came out from some of the winners. For instance, like 743 Cannes clients in Sweden were analyzing message idea executions framework, and 10% of the winners had AI as part of their campaigns. Another interesting insights of Cannes So the main uses of AI were voice recognitions and computer visions and text analysis. And this year Cannes, which is going to be held on June, the trend will be rising. So let's look at this data, which came from GumGum. As you can see, the numbers are quite interesting as well. So 68% of chief marketing officers report that their company is currently selling using and planning business using AI. 60% of organizations recently surveyed by Tata Consultancy Services use AI to increase media buying and so on. So needless to say that AI is very important within marketing industries. But what AI is good for in marketing? So there are 4 typical AI components that people use for marketing. It's optimizations, segmentations, targeting, and experience. And of course, this is the moment that people use that might evolve in the future. So to understand that, let's go through a few case studies. The first 2 components is optimization and segmentations. So the reason I choose those 2 simultaneously is that the case study that I'm about to show you involves both components that complete each other. So for this case study, it's harder than it's. They increased their conversion rate for more than 2,000%, which there's a pretty long story behind this. But ultimately, their system began by analyzing existing customer data. Then they isolate those 3 customers within 4 criteria. So those who either had completed a purchase, added an item to an online cart, viewed website content, and the top 25% of customers spends time on their websites. And using this information, the assistant identified lookalikes from any potential customers who resembled the past customer characteristics. And once the system discovers the similarities, it will process the customer even further by dividing them into microsegments. The reason being, so the system can test these segments through thousands of campaign variables and various digital channels like social media, search, email, SMS, and predict which one has the highest conversion rate. So as you can see, for this example, don't miss out a pre-owned Harley with a great price. Call now performed 400% more than ads containing the word buy. So once it determined what worked and what wasn't, the system scaled the campaigns and ultimately allocating resources from channel to channel, making content recommendations and so on. So in other words, the system allocated resources only to what had been proven to work, thereby increasing digital marketing return on investment, eliminating guesswork, gathering and analyzing enormous volumes of data. So and then basically increasing the insights. The next one is targeting. So for this case study, the first one is from Time and Sunday Times. They had a simple goal to increase registration for their website. So they came to Center Interactive, which is located in Dublin. They created a campaign to recreate the speech of John F. Kennedy when he was about to perform, but unfortunately got assassinated in 1963. So let's hear some of the speeches.
In a world of complex and continual problems, in a world full of frustrations and irritations, Americans' leadership must be guided by the likes of learning and reason.
So it's a bit long, but the last speech was created by feeding an AI system with 831 voice systems of JFK speeches and interviews. And this campaign generated 4,500 registrations for the Times and the Sunday Times. The next case study is this one. So I believe in general in depth, but in depth of Dali, absolutely not. It was a quote taken from Salvador Dali, and it was the main concept of DALI Live exhibitions. The museum collaborated with an agency called Goodbye Silverstein and partners. They used 6,000 frames and 1,000 hours of machine learning to train DALI expressions. So let's watch just a little bit of the clip.
Greetings. I am Salvador Felipe Jacinto Dalí y Domenech, and I am back.
Even though Dali's been gone for 30 years, we're using artificial intelligence to bring it back today. In order to actually train this AI to reproduce Dali's likeness, we've started with finding the right footage of Dali, and then we split that up into frames where he's looking the right way, and we pick the best frames to use for training from that. Our system learns exactly what he looks like and how his mouth moves and how his eyes move and his eyebrows and every little detail about what makes Dali Dali.
This is actually a recreated version of Dali. It's not a person playing Dali with makeup. It is actually Dali. We're very careful to use his words. So they learn a lot about what he thought and the way he thought. People want access to art. They want a way in. It could be through technology, through learning about the artist. Greetings. Welcome. This technology allows people to imagine for a moment that there is such a thing as immortality, to see Dali alive again. The whole future of Dali is explained in the roller painting.
I saw Dali, but like his actual form, full figure, speaking personally to me. It was welcoming to the museum, seeing his art, and like I still have goosebumps.
It is good to be back.
He talked about the museum and his paintings.
There comes a moment in every person's life when they realize they adore Dali. Your life is moment will also be known as one day. Go ahead to your friend. Mr. Dali, very life. Before you leave, you will take a picture with me? Honor. Dos, tres. Ooh la la! Would you like me to send you this dream photograph? Follow the instructions. What that adds is a sense of emotion. If they can empathize with this man as a human being, then they can relate to the work much more directly, much more passionately.
To understand the art, you need to understand the artists behind the art. And this technique allows visitors of the Dali Museum to do just that.
Okay, so go ahead. So since it was quite new and the campaign is running, there's no official result and has not been published yet. But in less than 2 weeks, they've received more than 1,000 views and being covered by various blogs and channels. So the next one is experience. This study perhaps some of the attendants have already heard. It's Netflix personalizations. So again, the concept is quite simple. Netflix automatically generates a custom artwork based on the user experience, based on the user preference. So let's say for good hunting, for instance, people who love romantic movies and comedy movies will be presented with a different artwork. So the result is, of course, increased click-through rates. So what did we learn from all those insights? I think some of the attendants here, especially who has strong interest in AI, understand that all case studies that were presented here had a simple approach. The DALL-E exhibition, we're using face swap. You guys can go there and test the code by yourself. And most of the machine learning that we did are using tools like, let's say, Crimson Hexagon or Google Cloud, AutoML tables that does all the heavy lifting. And then another thing is the basic rules. So first of all, understand the goal. Make sure the goal is quantifiable and measurable. Understand the data. A machine learning algorithm is only good as the data that is fed. Technical know-how, yes, knowing the concept of machine learning is important. And for a company, basically hiring the right people and changing company mindset is important, which we're trying to do in TBW Coder. And lastly, of course, imaginations. Thank you very much.
Thank you so much for the talk. I would love to take a selfie with Salvador Dali myself. Next, I would like to welcome our Takahiro from Mighty Hive, who is actually also our Code Chrysalis graduate. And he will be talking about introduction to k-means clustering. So please welcome Taka.
This is the
Sounds it's working. And at first, thank you very much for organizing this event by Code Chrysalis. And so I got the chance to explain about k-means clustering. And let me explain about the reason why I chose k-means clustering at first. Oh, okay. Is everyone able to hear my voice? Cool. And the reason is I got a situation to explain about k-means clustering to the client, but since I was not so familiar with k-means clustering, I was just working as a software engineer, so I couldn't explain very well. So we got technical resources from other regions, and I was working as just interpreters. So I thought it must be good to start to learn about k-means clustering, especially machine learning, everything. And this is the talk after learning several weeks, and I want to share with everyone what I found so far. And after this talk, I hope everyone who is not so familiar with machine learning will be interested in machine learning and to be diving into this kind of topic. And let me explain myself at first. And my name is Takahiro Moita, and as Nicholas introduced, I was an immersive program student at Code Chrysalis, CC4. And after graduating from Code Precise, I started to work in Mighty Hive as a technical solutions engineer. And I make mobile applications, and I do study into machine learning, and also provide solutions to the client, do sales pitch as well, everything related to technical things. And today's content is objectives and the difference between supervised learning and machine unsupervised learning, and then clustering, then go to the k-means clustering, and also limitation of the k-means clustering. So after finishing this talk, I would expect everyone to describe the difference between supervised learning and unsupervised learning, and also describe what is the clustering, and then the k-means clustering and the limitations of it. So what is the difference between supervised learning and unsupervised learning? The supervised learning is like, let's say you have a data set which is the correct answers, and you train your models. And after training, this data model can provide right answers with a future data set. This is the supervised learning. Like this example, this guy is training this kid as a data model, let's say. And after training this kid is able to ride on the bicycle by herself. I think it's very intuitive to understand. And what is unsupervised learning next? Because for the most situations, you don't have the right answers. In that case, what you can do? At least you can categorize the data set into the same patterns for the data with a machine learning. So I hope this is able to understand. And the one of the approach to use unsupervised learning is clustering. Like what is the clustering then? It's like you have the data set as I explained, and you want to make a group in the same data set. And another example is like this is a table diagram which I made a few minutes ago. And let's say there are two persons. The person A love to listen to specific music categories, such as like I love to listen to the hard metal. And the person B who loves to listen the different music, such as J-pop and R&B, which I don't like to listen. So if we made a scatter plot, it's going to be like this. So the person A and the person B will be plotted into the totally opposite positions. And how use this data? You can use to like, let's say you're working in the Spotify, and you want to make recommendations to your users. In that situation, you can use this data like, oh, personally I love to listen about the hard metal, so I can make a recommendation list with a hard metal. But it's not good to recommend about J-pop songs and R&B songs. It's good to recommend to the person B's. You can use these kind of situations. This is the clustering. So the clustering is a process to categorize the data and to optimize and push to the future use cases. And then go to the k-means clustering. And before going to the k-means clustering, I'd love to explain about the several terminologies such as centroid and distance. So in this case, the centroid is the data point which is in at the center of the clusters. In this case, the triangle. And another one is the distance. The distance is in this case, the distance is between the centroid and from other data point. And k-means clustering takes two processes. The first one is put the centroid randomly on the data set and compute the distance between the each data point to the centroid. and compare together with the previous one and the current one. And if there is a significant differences, and do these steps again and again until we could not find significant differences. And I think it's good to show the like demo. In this case, I'd like to go to this one. Oh no. And let's say you have the 3 clusters, and you would like to put the centroids randomly. 1, 2, 3. Oh, I think this is not good example. And we're gonna calculate the distance. And if there is still have the like a significant difference with the previous one, we would update the distance again. And again, until we found no difference. Like this. It seems like there is no difference anymore. Is it able to understand? No? Okay, let's do that again. We choose the centroids randomly and the Gaussian mixture to be simplified as an example. And put the centroids randomly again. And we calculate the difference between previous one and the current one. And it seems like there is still difference. And we still able to optimize.
I think people could not understand what difference is because
What is
the difference between what? Because I know it, but people cannot understand it.
Oh, you mean
I think it's better if you show yourself what the algorithm is doing because it's not very clear from what you are showing. It seems just that the centroids are moving towards the center of the clusters, but if you don't show how they do that,
I
it's hard to
see.
understand.
Yeah, that's a good point. I should have explained about that.
You can show the formulas of the algorithm with Wikipedia.
Yeah, that's good. Yeah, but I'm sorry because this time, yeah. Well, because of this time, just 15 minutes of the talk, I wouldn't love to go to the like mathematics models and dive into the like a program itself. But just kind of like a high-level explanations. So, bear with me. And let me go back to the slides again. And so the k-means clustering is like to make a group from the your given data set and to make the group in the same types of the data. But there is also the limitations of the data. Let's say there is a situation like these 2 data sets will be categorized with one data set, and this data set will be categorized with 2 separate data sets. And what is the situation? How do we put the centroids into this data set? And I'd like to have the answers from you, everyone. Does anyone have any ideas about that? Let's say I have the 3 centroids.
How many times do you usually randomize starting placement of centroids?
It depends on the location of the centroids because it's chosen randomly. And
like how many times do you have to run it until you get a consensus on the model for?
Yeah, there is no like a specific number for the calculation process. It will be continued until we found no difference from the previous centroids distance. Yes.
No difference means less than a threshold, but I think the unfortunate example is it picks a very clear example where it's very unlikely you pick a very bad initialization in that example. It means most of the times you cannot like get the clusters. But there are many other data distributions where you're not so lucky. Yes.
Thank you very much for your explanations.
I can talk with you later how to improve this maybe for next time. Yeah.
Yes, please.
No, for sure I do that.
And okay, I think this is the time to show the answers. The answer is like this, because we put the central in the center of these two data sets, and it's going to be optimized this distance and this distance, and putting two centroids into this one set, and the distance with of these two data points in this one cluster is optimized already. So this is the patterns. But in human eyes, it's obvious the clusters will be categorized with this one, and this one, and this one. But because of the centroids we chosen randomly, sometimes this kind of the clustering will be happen. But this is the limitation of the K-means clustering. And that's it from my side. Thank you very much.
Great, thank you so much, Taka. I know it was only 15 minutes time to explain a difficult concept. I think you did a great job, and hopefully we can have you back for a much longer talk as well. And lastly, but obviously, of course, not least, I would like to warmly welcome Tin from Zeihitomo. He will be talking about migration strategies and how to make sure that you save money later. Thank you so much, and please welcome Tin.
Hello, nice to meet everybody here today, and I want to say thank you to CodeList to give me a chance to talk here today. So today I'm talking about migration strategies. It's not super hard to understand, and it's more practical. So how many people here, can I have some number, like how many people here are building products, like doing startups? Quite a lot, so like 30%. How many people here are going to build a startup or to build a product? Only one or two? Okay. So I hope this talk is gonna maybe save you a little bit of money in the future. So based on my experience working at Adobe for 3 years. So I'm thinking I introduce a little bit myself. Currently I'm working at Adobe, so I want to put some logo here to explain easier. So CodeList is the host for today, right? And CodeList Tokyo is the community that I created last year. We had a 1 year birthday last 2 days ago. We can talk more about this if you are interested in, but basically I'm teaching programming to Vietnamese students for free. So here I'm the lead developer of Adobe, and also the founder of that community, and we have a team called CodeX to run the community. So in this talk, I'm going to talk about 4 main points. So why do we need migration? And what are the strategies to do so? And what are the pros and cons of those strategies? And some real life examples that I've done in the last 3 years. So why do we need migration? So migration is like moving part of the system from the old technology to the new technology, right? So for example, like a few years ago, I worked with AngularJS, and then we realized some problem with that. We tried to migrate that to React, so like changing some technology. So if someone here used to build products, and I think you already faced some problem like that in the past. So why do we need migration? First is things are changing, so new thing replace old things, optimize that, right? Second thing is like our solution that when you're new in your career, you make some decision and then after that you realize that it's not perfect anymore, it's not optimal anymore. Like the old solution became obsolete. Third reason is the product scales. So at the early phase of startup, you don't have money. You need to choose the minimal technology or solution to save your money and time. You don't have enough people to develop the whole beautiful system, right? Basically, you have only one small EC2 instance, and you need to fit everything inside there. What you're going to do, right? So the fourth reason is sometimes you may want to experimenting new things, like you see some new technology, you want to try part of the system to build on that new technology and slowly migrate the rest of the system. You think that the right solution. So there are a few different strategies, but here are the two main things. So based on my interview with some candidate, I asked a question like, hey, now I have an Angular app and I want to migrate to React app because Angular is not good. AngularJS is not good for SEO and we need server-side rendering. How are you going to do? And some people said that, okay, then I need to hire a lot of people and put all the effort in to try to catch up with the main product and develop the product at the same time. And I think, and that's one way. Another way is to find a way to slowly migrate the old system to a new system, piece by piece, so that you can divide a big cake into a small one, so when you eat that, you don't get stuck in your... I'm kidding. So it's called partial migration, so divide and conquer, right? So in the infrastructure code level, you can do that, or user level, you can do that. For example, you have 1 million users. You only want to release that feature to a small set of users so that you can test that if the new feature you're going to release is going to work or not. Because you may make mistake, or when you release it may cause some bug you are not you didn't expect, and try to reduce the risk. That's the way. So I prefer the second way, even though sometimes if necessary we may need to do the first way as well. So the pros and cons of the two solutions here is basically divided into different categories, like team effort, estimation, maintainability, and the risk may happen. So for the first one, I think it will take a lot of team effort. Like the estimation is so hard to make because you need to do everything at once. And usually when you do something new and you need to do a lot of work, then the estimation becomes harder. Maintainability, I think the first one may be easier because once you have all the system fully migrated, then you just work on that. You don't need to maintain two systems at the same time. The risk is, I think the first one has a risk of estimation because usually it will be underestimated. For the second one, the risk is there's sometimes the two systems doesn't work well together. In some cases, you didn't cover. That's it. So I want to talk about 3 different stories in the last 3 years about front end, back end, and the infrastructure. So front end, from the beginning of the demo, we use Angular and Firebase to build a prototype to make it work on mobile. Later, we realized that AngularJS is not version 2+. So we realized that AngularJS doesn't work well for SEO, even though we try a lot of things like prerender.io, right? That's the service and they open source that. We set up that, but it still takes a lot of time for Googlebot to crawl data, and it never works. I don't know why. So we decided to migrate to React server-side with server-side rendering. I will explain more about that right after this slide. So also Firebase, at that time, it's like 3 years ago, it's still new, it's not fancy like right now. So the real-time database has a lot of limitations. For example, like you can only index one field in the collection, and like you need to store the ID in a weird way, or like some denormalized data. It's really hard to work with. Also, like pagination, whatever in the database engine doesn't support. So this is the way. This is one method of migrating AngularJS to React. So I talked with different companies, and some of them doing this way, building React component, and then so on top of AngularJS framework, building React components. And in the future, once all the component is already built, then they just need to switch the logic, rewrite the logic from Angular to React. But this way, it doesn't work because it's really hard to do server-side rendering as well. So I chose this solution, which is to start a project from scratch. So Angular and React from scratch. Like that, there are different advantages. For example, you don't need to maintain the Angular page for that feature we want to migrate. For example, like at Adobe, we are a local service marketplace, right? So we have different landing page for different verticals, like slash photographer, slash English teacher, slash like house cleaner, whatever. So we decided to migrate one by one first to see how it looked like. The first page we migrate is not a photographer, it's like English teacher or something like that. The way I did is to build that only one page in React is really fast, and we know how long it's going to take. So it's like 2 weeks. And then we set up a load balancer. I call it reverse proxy. It's almost the same. So whenever user enters, whenever user found Zehidomo on Google, when they type photographer near me, something like that, so Zehidomo comes up with zehidomo.com/photographer, then they will be redirected to this React instance, React cluster. And if not, then go to Angular, right? There are a few more like complicated things inside. For example, like if you're inside Angular already, but there's some internal link that goes to photographer, how would you do? So the way I chose is to do a force reload like that. It will go back from here and then go to React again. That's one story. Actually, we have Firebase for front end as well. So that's half the story of the front end. This is another story. This is pretty fun because at that time we have only one developer, which is me, and we realized the problem of Firebase in the early phase. So Firebase has like object-based, right, database. So it's really close to MongoDB. So that's the reason why I chose MongoDB at the time to build the backend. So in order to maintain the real time of the system, so we decided to use Socket.io as well. There are different ways to do that, but I chose the way to write exactly the same API like Firebase, but the implementation behind it is different. So it uses WebSocket and MongoDB Express.js to handle the data synchronization. So like that, once the library, I call it a small library, is done, and it's exactly the same interface. So the only thing is to change switch the library. That's done. For the backend, we did the same thing. So set up the MongoDB server Express.js socket, right? So we realized some problem with the authentication, which is really hard. So this is the backend I built for that. It's not optimal, but it solved the problem at that time. We don't have a lot of users So I decided to go with that way, and in the future we'll migrate again. So working in a startup is fun like that because you need to keep balance between the speed and the quality, because cannot always build a perfect solution and don't know if that works or not, right? So before we migrate from Firebase to Merge Stack, it looked like this. So Node server connect to the Firebase database, and Firebase connect directly to the browser. And after that, so the fun thing here is the ORM thing. So in order to not writing a lot of new code, then I chose an ORM called JS data. And that's the only ORM that support Firebase at that time. So I'm lucky because I don't need to make different decisions. So ORM will be the layer on top of the implementation of the database, right? And then you can choose either Firebase adapter or MongoDB adapter. And you can switch that easily if you have, let's say, in Firebase you have user collection, and in MongoDB you also have user collection. And then the only thing you do is, okay, change adapter only one string, like Firebase to MongoDB. Even there's some problem that I didn't test it carefully, and there's some inconsistent behavior in the library, but we have some workaround to fix that. For example, like with Firebase, when you cannot find a document inside the collection, it returns you null. But with MongoDB, it throws error, so that's kind of weird. So I need to write another wrapper method to deal with that. And socket.io to maintain the real time. The last one is the infrastructure. This is a long story, but I will make it short. So if you are interested in learning more about this, just talk after. So Heroku to AWS. Heroku, from beginning, we use Heroku and we pay like $10 per month or something like that. And for some, it's getting harder, like more expensive, and also the server is not in Tokyo, it's in the US, so it's a bit slow. So we decided to move to AWS, and we started with only one instance to save money, and I built a bunch of Docker containers inside there for different services with an Nginx as a reverse proxy, and that instance we have elastic IP to make sure that when it restarts, it still has the same IP. And later that, when the system scale a little bit, we migrate to elastic VTop, and then we are moving to Kubernetes. And yeah, that's all the story that I want to share with everybody here. So if you are interested in talking more about this, let's talk later after this. So, thank you.
Thank you, Tin, and thank you to all of the 5 speakers. Can I get one more round of applause for the amazing 5 speakers? Just a couple of brief announcements I would like to make. Jan already mentioned the 1st of June, which is next week, Saturday. We have the big MiniConf. We will have 10 30-minute tech talks. It's a Saturday from 1 to 5. You can drop in anytime you want. And also, if you are interested in speaking yourself, or if you thought this is something you would like to maybe do, please feel free to reach out to me or hello@codechrysalis.io, and we can take it from there. But now we have the space, so please feel free to mingle a bit, talk to the speakers. It was only 15 minutes, a lot of topics were uncovered, so please use this time. And thank you so much for coming tonight. Thank you.